Let's see how to get those confusion matrix values. We're going to go in and modify our task. Modify task down here under options. We're going to click show classification table, and we're going to put in 0.5 to get our first confusion matrix, first set of confusion matrix variables. We'll hit run. And so now what's going to happen is our logistic regression model is going to go through and assign every observation with a predicted probability of being approved of greater than 0.5 and to be predicted to be approved. Everything with a predicted probability less than 0.5 to be predicted to be rejected. And so we get this classification table down here. This classification table should have numbers that you recognize from the Blackboard. We've got 245 correct events. So what this is telling us is that of the observations that were approved, 245 of them were correctly identified as being approved. Of the observations that were rejected, the loans that were rejected, 565 were correctly predicted to be rejected. So those are what we call the main diagonal entries on the confusion matrix. Add up those two, we get 810, or 81% of the 1,000 original observations were correctly predicted. The 73 and 117 here are our incorrect predictions. And the way Enterprise Guide labels these is the incorrect events are observations that were predicted to be an event, predicted to have whatever it is we're modeling. In this case, it's 1, approved equals 1. So we're predicted to be approved, but we're actually rejected. 73 loans were predicted by our model to be approved, but were actually rejected. And this 117 incorrect non-events is loans that were predicted to be rejected, but were actually approved. I always have a hard time remembering which way around these go. My way of trying to figure it out on the fly is to figure out exactly how many approvals I have, exactly how many ones I have. For that, I can go up the top here, 362 ones. So 362 people were actually approved. And as I scroll back down here, whoops, I skipped over it, adding these two together, 245 plus 117, gives me 362. So these two are the ones that were actually approved. These ones were correctly predicted to be approved. These ones were incorrectly predicted to be rejected. Okay, so next we can change that 0.5 cutoff that we selected. In fact, we won't remove the 0.5, we'll just add in a 0.25. And as we do this, we're going to now get two different sets of values for the confusion matrix. Now, in order for a loan to be approved, to be predicted to be approved, we're only going to require its probability assessed by the model to be 0.25. So now we're going to get more of our loans predicted to be approved, fewer predicted to be rejected. So with this 0.25 probability level now, we're getting a larger number of our loans correctly predicted to be approved, but we're getting more loans incorrectly predicted to be approved. And this is just a consequence of changing this probability level down. If we changed it up, we would get the opposite result. And so now based on these, we can calculate the sensitivity and specificity. With a probability level here of 0.5, we get a relatively insensitive model, but relatively specific. With 0.25, we've got a more sensitive but less specific model. And then we see these graphed on this ROC curve. this ROC curve graphs all possible probability levels, ranging from 0 up here down to 1 down here. And the ROC curve is a good way of getting an overall picture of how well the model is performing. Generally, the larger the area is under here, the more easily we can choose a model that's going to have relatively high sensitivity and specificity. If this ROC curve is close to this diagonal line here, and that's going to indicate a relatively poor model, one where we can't get as sensitive and specific a model simultaneously.